Hello and welcome to the screencast. Tonight I'm going to solve some of the problems that you might expect to see on tomorrow's quiz on factoring higher order polynomial expressions and solving higher order polynomial equations by factoring. In problem 1 here we're asked to factor the expression 42p cubed plus 7p squared plus 12p plus 2 completely. Now I can tell what factoring technique I'm going to be using based on how many terms there are. Since there are 4, I know that I'm going to be doing factoring by grouping. So to do factoring by grouping, I'm going to draw parentheses around the first 2 terms and parentheses around the second 2 terms, and then I factor each set of parentheses independently. So in the blue set here, I can see that I'm going to have a common factor of 7p squared. So I'm going to factor out 7p squared. It's going to leave me with 6p plus 1. Now I'm going to factor the 12p plus 2. And I can see that I'm going to be able to factor out a 2, giving me 6p plus 1. Now I'm ready to do the combining step. And when I combine, what I do is I take that 6p plus 1, or whatever binomial appears in your problem, and I'm going to put it there, and then I form another set of parentheses using the 7p squared and the 2. And that's all there is to it. None of those binomials can be factored any farther, so I have finished the problem. The first secret word of the secret sentence tonight is April. Alright, now the next problem looks like I also have 4 terms, and so I'm also going to be doing factoring by grouping. However, I always want to look to see if there's a common factor before I use any technique. And if I look here, I can see that there would be a common factor of 3. So let me factor out the 3, and that leaves me with 6r cubed plus 2r squared plus 15r plus 5. Now I'm going to do my factoring by grouping. So the first set I'm going to factor is the 6r cubed plus 2r squared, and I can see that I can factor out 2r squared, leaving me with 3r plus 1. And now I'm also going to factor the 15r plus 5. So I can see that I'm going to factor out a 5, leaving me with 3r plus 1. And at this point we haven't forgotten about the 3 we factored in the first step of the problem. It's still there. We're still going to use it. It's just pretty much along for the ride at this point. Alright, now I'm to the point where I bring down the common binomial, which is going to be 3r plus 1. And what forms the other part, the other binomial, is going to be the 2r and plus 5. And the 3 still goes out in front, and since none of those terms can be factored any farther, I know that I've finished. Alright, in the next set I have 3 terms, so I know that I have a trinomial here, and I'm going to factor it the way I usually factor a trinomial. The only difference is I'm going to have an exponent of 2 with the x in the beginning of each binomial. Alright, so I need 2 numbers that multiply to be 70 that add up to 17. Well, that would be 7 and 10. And neither of those binomials can be factored any farther, so I know that I have reached the end of the problem. Alright, the next one is also a trinomial, but I can see that I have a common factor of 6. So I'm going to factor it out. and I get this. Alright, now I need two numbers that multiply to be 15 and add up to -8. Well, that would be, let's see, -5 and -3. Now, neither of those binomials can be factored any farther, so I know I have my answer. Second word in the secret sentence tonight is the word is. Alright, number 5. Okay, I have two terms, and I can tell that both of them are perfect cubes. So I'm going to use the sum of perfect cubes formula. But first I have to write 27x to the third power as something to the third power. So it is, not u, but don't ask me where I got the u, 3x. 8 is 2 to the third power. Alright, the formula for factoring the sum of perfect cubes is this. Third word, secret word in the secret sentence is the. Alright, I think you can see that 3x is going to go wherever the a appears, and 2 is going to go wherever the b appears in this problem. So my factored form then is going to be 3x plus 2 times 3x squared minus 2 times 3x, and then plus 2 squared, which is 3x plus 2 times 9x squared minus 6x plus 4. And that's it. Alright, in the next one I also have perfect cubes, but this time it's the difference of perfect cubes, and I see that I'm going to have a leading or a GCF to factor before I get to the perfect cube part. So it looks like I'm going to be able to factor out 3, and that's going to leave me with 64 minus m cubed. Alright, now 64 is 4 to the third power, and that means an m cubed is just m cubed. So I think you can see this is going to follow the pattern a cubed minus b cubed, which is equal to a minus b times a squared plus ab plus b squared. So I'm going to put a 4 in wherever a appears and an m in wherever b appears. And that's going to give me 4 minus m times 4 squared, which is 16, plus 4 times m, and then plus b squared, so that's m squared. And that's it for that problem. Alright, the next secret word this evening is the word cruelest, as in C-R-U-E-L IST. Okay, in number 7 and 8 I'm actually asked to solve an equation. So I start off the same way as I do with the factoring problems, in that I have to factor. So I can see from the fact that there are 4 terms here that I'm going to be doing factoring by grouping. So let me factor the first 2 terms. I can see that I can factor out an x. It's going to give me x plus 4. Now let me factor the second 2 terms. Well, there's no GCF to factor. That means you can really factor out a 1. Alright, now it follows the pattern of factoring by grouping. And so I'm going to bring down the x plus 4, and then the x squared and the 1 are going to go here, and the equal 0 still stays the same. Alright, so the key step now to solve by factoring is to set each factor equal to 0 and solve the little equations that you get. So when I do x plus 4 equals 0, I'm going to subtract 4, and I get x equals negative 4. So that's one of my solutions. Then for the x squared plus 1 factor, well, if I said x squared plus 1 equal to 0, I'm going to get a quadratic equation that I'm going to solve by taking square roots. So to do that, I'm going to isolate the x squared on one side of the equation, and then I take the square root of the left and the plus minus square root of the right. Okay, that gives me with x, and what's the plus or minus square root of negative 1? Well, the square root of negative 1 is just I. So I'm going to have plus or minus I. That means the solutions to the equation are negative 4 and plus or minus I, meaning I and negative I. Okay, and in the last problem here, I have a trinomial on the left side of the equal sign. So I know I'm going to be doing quadratic form factoring. And I'm going to need two numbers that multiply to be negative 56 that add up to negative 1. Well, that would be minus 8 and x squared plus 7. Alright, so now I'm ready to set each factor equal to 0. So, and solve. So that's going to give me, let's see, I'm going to add 8 to both sides on this one. That gives me x squared equals 8. Now I take the plus minus square root of both sides of the equal sign. And I get x equals, let's see, plus or minus 8 is 4 times 2, so that's 2 radical 2. And then in the other factor, when I set it equal to 0, I get x squared equals negative 7. So x is, let's see, I'm going to take square root of both sides, plus minus on the right. I get x equals plus or minus, now the square root of negative 7 is I times the square root of 7. And I have my 4 solutions. And they are plus or minus 2 radical 2 and plus or minus I radical 7. And the final word in tonight's secret sentence is month. Alright, I hope you've found this screencast helpful, that you picked up on what the secret sentence is, so you can get extra credit on tomorrow's quiz. And have a good evening, and let's hope that, I'm hoping we have school tomorrow, but please know that if we do not have school tomorrow, we are going to take this quiz on Monday, so you'll have extra time to send me the secret sentence. Alright, have a good night. Cheers.